High-tech construction does not automatically mean better. We look at engineered foams and chemically complex aerogels and assume that they're the peak of building science. But the data suggests that an agricultural waste product might actually outperform them all. I'm talking about straw bale construction. Not a primitive hut, but a high-performing building envelope. What happens if you put a straw bale head-to-head against modern industrial insulation to see which one actually wins on thermal performance, carbon, and safety? First, we need to be very precise about what this material is. There is a massive misconception that straw buildings are built from hay. This is wrong. Hay is dried grass with seeds in it. It's food for animals, it rots, and it attracts pests. You can't build with hay. Straw is the structural waste product of the grain industry. It's the dry, hollow stalk of the wheat, barley, or rice. Because the stalk is hollow, it essentially is a tube of trapped air. And in building physics, trapped air is insulation. There are two distinct ways that we can use this in modern construction. First is the load-bearing method. This is where the bales themselves act as giant structural bricks that hold up the roof. You can stack them in a running bond, pin them with hazel or bamboo, and then mechanically compress the walls down. It creates an incredibly sturdy, strong structure. The second method, which is becoming the industry standard for larger projects, is the infill or timber frame method. You build a standard structural skeleton out of wood to carry the loads, and you use the straw bales strictly as insulation blocks to fill the voids. But the most critical part of the system is the plaster. You never leave the straw exposed. You encapsulate it in a thick layer of lime or clay render. This turns the soft bales into a composite structural insulated panel. It becomes hard, durable, and airtight. So before we look at the numbers, we should probably look at the application. This isn't just for self-builders in the woods, it's happening at an institutional scale. Look at the Enterprise Centre for the University of East Anglia right here in the UK. This is a massive multi-storey university facility, and it's clad in thatched straw panels fabricated off-site. This is so that they don't become wet if it rains when it's on site. It's one of the greenest buildings in Europe. Or look at the Maya boutique hotel in the Swiss Alps, which uses load-bearing straw to survive freezing winters with almost no active heating. Or the S House in Austria, which meets the rigorous Passive House standard using straw walls. This is a proven commercial grade technology. But how does it actually compare to the modern, more standard stuff? Well, I'm going to break it down into 4 rounds: thermal efficiency, carbon, fire, and health. If your only goal is to get the highest insulation value in the thinnest possible wall, then modern insulation wins. Materials like PIR boards or phenolic foam are chemically engineered to resist heat flow. You can hit a standard U value for a wall of 0.18 with a wall that's just 100 mil thick. Straw is just less efficient by volume. To get that same U value, your wall should be around 450 mil thick. So if you're building in a dense city centre where every square inch of floor space is a lot of money, then modern insulation is just the winner. Straw takes up more space. However, round 2 is embodied carbon, which is where modern insulation fails completely. Foam insulation is a petrochemical product. It requires massive amounts of energy to manufacture, and it emits carbon before it even gets to the building site. Straw is the exact opposite. As the wheat grows, it pulls CO2 out the atmosphere through photosynthesis. When you construct a building out of straw, you are taking the captured carbon and locking it into the walls for 100 years. A straw bale house acts as a carbon store with tons of sequestered CO2. If your goal is net zero or carbon negative architecture, then straw is the undisputed winner. And now is round 3, something that many people are rightly worried about: fire. There's a myth that straw houses are fire traps. The science, however, just says otherwise. Straw bale walls have passed 2-hour fire resistance tests and can actually outperform standard timber frame walls. That might sound strange, but the reason is oxygen starvation. If you have a loose pile of straw, which is what many people think a straw bale construction is, then it burns instantly. But a bale is compressed under high tension. It's so dense that there's just not enough oxygen inside the bale to support combustion. When you cover that in non-combustible lime plaster, then you have a wall that's incredibly resistant to flames. It actually tends to char rather than burn. And then the final round is the building health. Modern homes wrapped in foam and plastic vapor barriers are airtight, but they can't breathe. If the ventilation fails, then humidity builds up and you get mold and something called sick building syndrome. Straw walls, when rendered in clay or lime, are vapor permeable. They can absorb moisture from the air when you're cooking or showering and then release it when the air is dry. They passively regulate the indoor humidity, which prevents mold and creates a much healthier, lung-friendly environment. Plus, the sheer mass of the bales provide acoustic soundproofing that lightweight foam often can't match. So the all-important question, who wins? Well, if you're strictly measuring wall thickness, then modern insulation is still the king. But if you're measuring performance on a whole system, the carbon footprint, the fire safety, the acoustic comfort, and the indoor air quality, then straw bale construction is actually superior. It's a regenerative technology that solves problems modern materials create. On this channel, I talk about sustainable building materials, technology, strategies, and buildings. If that interests you, subscribe and click here to watch the next video.